In this video, we consider the notion of Granger causality in vector autoregressive models. In previous videos, we have considered ADL models and structural VAR models. For these models, we directly imposed some a priori causal structure on the variables entering the models. Granger causality is different in the sense that we do not a priori impose such structure. On the other hand, Granger causality cannot say anything about contemporaneous causality. We may define Granger causality as follows. So consider the so-called forecast error obtained by forecasting some variable y at time t plus h based on the information set until time capital T. Likewise, we may define the forecast error obtained by forecasting based only on the observations until time t, capital T of the y variable. This forecast error we may label eta h tilde. By construction, eta h is the difference between yt plus h and its forecast based on both variables yt and xt until time t. And likewise, eta h tilde is the value of yt plus h less its forecast based on only the information set induced by the yt variable itself. We then say that the x variable Granger causes y if for some forecast horizon h it holds that the forecast error variance for the forecast based on both x and y is less than the forecast error variance related to the forecast only based on the y variable. So essentially, if this holds, it means that the variable x can be helpful in forecasting the y variable. If the two quantities are equal, we do not gain anything by including x variable in our forecast of the y variable. Note that the underlying assumption for this notion of causality to work is that the cause, namely some change in x, comes prior to the actual effect of x on y. What you should have in mind is that we essentially just quantify whether x is a useful variable for predicting y if we already can use the past values of y to produce the forecast. In a bivariate VAR model, it is straightforward to test for no Granger causality. So for instance, if we want to test if x does not Granger cause y, then we can simply test whether the autoregressive matrices are lower triangular, meaning that we can test whether a12 and b12 are equal to 0. If these two coefficients are equal to 0, then we cannot use xt to predict future values of the y variable. Likewise, we can test whether y does not Granger cause x by testing whether these two VAR matrices are upper triangular, namely by testing if a21 and b21 are equal to 0. We can use a likelihood ratio test or Wald test for testing such hypotheses here, and we're imposing two restrictions. So under correct model specification, we will have that the test statistics are asymptotically chi-squared distributed with 2 degrees of freedom. Note that this kind of test does not tell us anything about contemporaneous causality. So it doesn't tell us what happens to yt if there is a change in xt. Let us consider a simple empirical illustration. So we will revisit the VAR2 model for the quarterly growth in US real GDP and the quarterly returns on the S&P 500 index. We estimated this model in a previous video, and we found that a VAR2 model is reasonably specified, although the error term appeared to be heteroscedastic. So if we want to test for no Granger causality, we may use a robust Wald statistic. we estimate a VAR2 model for the change in real GDP and the quarterly return on the S&P 500 index. And we use heteroscedasticity robust standard errors. We can then start out by testing whether the growth in GDP Granger causes the returns on the S&P 500 index. Note that this boils down to simply testing whether we can exclude the lagged values of the y variable in the equation for the return on the S&P 500 index. And we test whether these two variables can be excluded. We get a robust VAR statistic that is around 1.3. So based on a critical value from a chi-square distribution with 2 degrees of freedom, we get a p-value of around 50%. So we accept the null hypothesis that the growth rate in real GDP does not Granger cause the returns on the S&P 500 index. We can also test the other way around, namely test if the returns do not Granger cause the growth rate in GDP. And here we get a much higher robust VAR statistic and a p-value of around 1%. So we reject the null hypothesis that the returns do not Granger cause the growth rate in GDP. So another interpretation would simply be that we can use the returns on the S&P 500 index to predict future growth in real GDP. So I've included the estimation output in this slide here. Thank you for watching the video.